Hi everyone. Today we'll talk about better practices for crafting automated tests. And just to get some things out of the way, I just want to make sure that we set the bar to understand that I'm not going to be talking about the pros and the cons or the usefulness of automation or about the processes. It's not about automation strategy. This is about for test automators, how to write better automated tests, how to improve your test code. And that's what we're going to be focusing on. So for the past year, I've been looking at some of the code within Microsoft where I work. I've been looking at some of the code in other places, other teams that I've been working with, and also I've been looking at how my students at the University of Washington write test code when I'm teaching them. And so there's some things that we do when we're writing code, sometimes because we get into a rush or there's so much pressure to get so much done that we make some mistakes. And one of the things that I've learned over the past year, especially from doing a deep dive into massive stacks of test automation, is that there's a couple things that we can do to really improve the robustness of our automation and also reduce our long-term costs around maintainability. So the first thing I'll do is talk about basic tenets of automation, test automation, just to give you my mindset a little bit. And then also, there's many things that we can do, but I picked 5 practices that are pretty easily implemented to really make a pretty significant difference in the reliability and robustness of automated test cases. And then finally, at the end, we'll ask, you can ask questions, and I'll be able to answer those, I hope. So let's look at the basic tenets. The first thing is about, make sure that the tests that you automate provide information that enable the team to make decisions. I see a lot of automation that really, when you get down to it, if that automated test fails, do we really care? Or is it really providing the information that is most critical to the success of our product? I'll give you one quick example here. In one test that popped up on my radar a few months ago, it was actually a test in which the person had written an automated test to post a tweet to Twitter, and to a fictitious Twitter account, and the tweet was 1 character long. Now, I'm pretty sure that I have an idea of what this person was trying to achieve, and that my idea was that they were probably thinking that they were testing some magical boundary. However, the problem with the test, and the reason it popped up on the radar, was because Twitter does not allow you to post the same tweet within a 24-hour period. And so when I looked at this test, there were so many things wrong with it. First, if it was a boundary test, we don't need a boundary test running every day. And a boundary test should not be a functional test, it should be a unit test. Another thing that was wrong was they were posting the same character. They weren't even trying to randomize which character they were trying to post. So the whole idea of having this test in a functional suite just did not make sense at all. So you really have to be careful about what sort of tests you're going to automate. Very honestly, there's some tests that just don't make sense to automate, and we should rely on self-hosting, we should rely on betas, we should rely on manual testing, or our customers to tell us that there's a problem. So below are some ideas for what type of tests that we typically automate. We're looking at critical functionality, Non-functional behaviors such as performance and stress, security, those are the things that we really spend a lot of time automating. Another area that we want to automate, or that can provide some value, is the customer scenarios. What the tasks that we think our customers are doing on a regular basis. Now, certainly we don't need to run these every day, but there's some, like regression tests, that should be ran every day because they give us a general indication of the health of every new build that we get every day. The other thing I see a lot that happens is that people who write test code tend to script things out, and they just assume things are going to be happening, just like when we run a test manually or execute a test manually. An automated test will fail exactly 30 seconds after you leave the room. So you can't assume anything is going to happen. If you want to save a file, then you have to assume that when you save that file that you might get an error dialog that indicates that file name already exists, or that file might be corrupt, or any other transient error message that might pop up in that file save process. So you really have to understand the system a lot deeper when you're automating, and be prepared to handle these anomalies that might occur in the system when you're executing a task. When we do these things manually, we can see them and deal with them. From an automation perspective, we have to be able to predict them and then actually put something in our code to deal with these anomalies. And then finally, I would highly recommend coding early. Now, this seems to go against the grain, especially for many people who are familiar with GUI testing and GUI automation. I've working with developers, writing unit tests, and working in a foundations team working on API testing. We are actually able to provide to find bugs in real time as the developers are submitting their code. So if you're doing unit tests or if you're doing API tests, coding early is very, very important. As soon as I get an API signature, I can start writing the automation for that, and when the developer checks his or her code in, my tests are running, or our tests are running, I should say, and actually detecting bugs, or functional bugs, very, very early. I do believe that those same sort of things can occur in GUI automation. Of course, you do have the possibility and really the high probability that UI may change during the development lifecycle. Okay, so the first thing that I want to talk about is getting organized. One of the things that I really see, or that I tend to see in a huge automation stack, especially in my current team, Windows Phone, where we have close to 1,000 testers writing code, is that when I moved from one feature team to a different feature team, the code, I had to relearn how to read the code, because the coding styles between teams, and sometimes even within teams, was very different. And so one of the things that I did for my class at University of Washington is I created a template. And this is essentially what the template looks like. But if you have a template that everyone on the team is using, it makes reading the code so much more easy. Regardless of who on the team is looking at your code, or later on when somebody has to maintain that code, then the ease of use and the maintainability of that code becomes so much easier. Some of the best practices that I've seen that within Microsoft and other places is having a great summary. So when we write a test method, that you're supposed to have a summary of what that method does. Well, not only do we have in our summary for the method, we have an objective, basically. What is this test trying to do? So we have our objective, and if we can articulate what this test is trying to do, then it makes things a lot clearer when we're actually writing the test. Sometimes when I'm teaching, I'll go over and I'll ask a student, so what is the purpose of your test? Or, what are you trying to do here? And the student will say, well, I'm trying to code this. I'm trying to make this happen. I said, no. Explain to me what the purpose of your test is. And they sort of look at me with this blank look. They have an idea of what they're trying to code, but they never step back and think, what am I trying? What is the purpose? What am I trying to achieve with this code? The next thing I found was having steps. So if we can articulate the steps in the summary as well, then it helps us when we're actually writing those steps in code and writing those statements in code. And then finally, a lot of the things that one of the things that we do very well, a lot of times when we look at test cases or we think about test automation, we always talk about test automation in regards of pass-fail results. But it's very, very important to remember that sometimes during the execution of an automated test that something may occur. A window handle may return null, or you may run out of memory. And so in those cases, we're going to try to catch those exceptions when they're being thrown. And when an exception is thrown, then that test is actually, that we abort the test, and that test should be reported as blocked. The next thing it comes from something I've learned from outside of Microsoft. At Microsoft, all our code is treated the same. We do not separate our source code, our product code, from our test code. It's all built into the same build tree, and just like the developers, we use the same source control mechanisms. We use the same tools that our developers use. So source control is imperative. We have to remember that the test automation code is one of the most tangible things. Just like test cases, it's one of the most tangible things that we as testers produce. The other thing is that in some teams where you have test code or you have products that have to be maintained for a period of several years after the product is released, then having those tests, having those automated tests under source control and easily distributed for running when you have to update and fix that prior release build, it's very, very important. So now you know where everything is. And it's easy to go in and change things if that is necessary. Also, I saw a question on SQA Stack Exchange once about when to commit code. And as a general rule, I would say commit early and often. Essentially, anything that you don't want to lose, you should commit. Now, in our system, we can commit code. We can actually check in as much code as we want, test code, and that test isn't turned on until we actually flip a switch in our test harness. So we don't have to worry about code getting into the build inadvertently and causing problems. Test code, we have a fail-safe system that our test code goes in, but the code is not actually activated until we flip another switch. Also, static analysis. So when I look at code, it's not just amazing how different it is between different test developers, but it's amazing how horribly written it is as well. One of the best books I've read is a book called Clean Code, and I firmly believe in the idea of clean code. It improves readability. the robustness. There's a wonderful tool that's available for C# users called StyleCop and FXCop. Java, there are similar tools in Java for JavaScript, and basically what these do is they look at your code, they make sure that you have headers for all of your properties and all your methods. They make sure that that even spacing is consistent throughout. And trust me, after looking at hundreds of thousands of lines of code and looking at different groups, having some consistency in code is very, very important because it makes the reviewability much easier. Going between different coding styles really is almost like learning a different language, even though you're looking at the same programming language. Having consistent coding guidelines in your organization is also very important, and then doing peer reviews or code reviews prior to check-in. So one of the things that we instill upon new testers at Microsoft is that before you check in your code to the branch, it has to be submitted to a peer review. At least 2 other testers have to look at it and give you feedback. And of course, one of the things that we require also is that before you even submit for the peer review, is that it goes through StyleCop and FXCop. If it doesn't go past those tools, we don't even get it into the code review stage. So having that the style and having clean code is one of the things that will really help in the maintenance costs and reduce maintenance costs of test code. Now, a lot of times when I'm looking at test scripts, not necessarily, then I see something similar to what we have here on your screen of this sort of deluge of statement after statement after statement after statement after statement. And I found this example on the internet, and I'm not, yeah, and it's pretty clear what they're looking at. They're looking for a file replay. They're looking at not opening a file. They're doing a find replace in Notepad, and then they're closing the file. But all I see here is just a lot of execution statements. And so when I look at these, I'm thinking like, wow, there's probably other tests that I have to think of, or that I can think of, where I would need to open a file and where I would need to close that file. And so this is just mind-numbing. You know, it numbs the mind having to read script like this that just goes on and on and on. And it's also very expensive. So when I looked at this, I started saying, you know, what are we really doing here? What is the test steps that I would do if I, as a person, were to do this? Well, I'm going to launch the application. In test code, I need to get the handle of the application. One of the reasons, and if you're not familiar, once I have the handle to a window, whether that window is the main window or the handle to a window, button window, I own that window. I can do anything with it. So you'll sometimes see a lot of automation code where once you launch the application, the first thing you do is you get the window handle. The next thing I'm doing is I'm opening up a file. I'm going to replace the text. I'm going to replace all the text in that file, and then I'm going to save that file and close the app. Now, for you people that are really quick, you'll notice that there's a lot of things. There's some things that are missing here, but there's one thing that's apparently missing, and that is the oracle, the thing that tells us whether this test actually passed or failed. So if I took those scripts or if I took those ideas, those concepts, those tasks that I'm going to do for this test, and the objective of this test is to replace all within Notepad, then one of the things that I would do is separate all those execution steps to click the file menu, get the dialog handle, find the edit combo box on the open dialog. Here we're clicking coordinates, so on and so forth. I would take all those steps and I would code them into a separate method. And again, in this case, I would put them into a helper class for Notepad, for any other people who are writing test code against Notepad. And so basically we took 22 program statements out of this test case and cleaned it up to make 6 task statements. So again, we're opening up Notepad in the first one. We're getting the main window handle. Then we open the file. We replace all text within the file. We save the file, and then we close application. And then there's our oracle to verify replace all actually occurred. In fact, I could have even shortened this by 1 step, because at the same time I launch Notepad, I can also pass an argument to open a specific file as well, if that's what I wanted to do. So there's many different ways, just like when we're testing a piece of software manually. In automation, there's many different ways that I can write my test to achieve different or go down to different paths. This is an example of where I've taken the replace all code and put it into a wrapper method. Here, so now you can see I'm clicking the menu, but instead of clicking menu coordinates, I'm actually using ordinals for menu items. Now the ordinal value of a menu item, of course, could change over time. There's different ways to solve this problem. Ordinals was cheap and easy, and for a product like Notepad or something that's been around a while, it's pretty stable to use. Next, I'm getting the dialog handle, and I'm getting I get the handle to the text boxes, and now I'm calling a method to set text box. Actually, in these methods, one of the things that I'm doing is, instead of trying to navigate the dialog by coordinates or navigate the dialog by using key mnemonics, access key mnemonics, one of the things that I'm doing is I'm getting the handle to that control, in this case the text box, and then I'm calling another Windows API to post notify message to actually inject the text into that text box via its handle. That way I know exactly where it's going. And then finally, and so I put text into the replace, put text into the find, and then press the replace all button, and then I close the dialog by pressing the cancel button. If at any time that if any of these steps fails, if I can't find the replace text box, for example, or if the replace all button is still grayed out and is not active, then that code, the method that I'm calling there, will actually throw an argument null exception. And so then I'm going to rethrow that argument null exception back to my test. My test will then catch that exception and report a blocked rather than a fail. And then finally, my oracle. So I wanted to include my oracle in this method because one of the things that I'm doing, just like I removed my test steps, I'm also going to remove and take out my oracle. I don't want to code my oracle inside the body of the test as well. And this is one of the the oracle is a case where less maybe not is better, but more is better. So the more checks I have to know whether or not my test actually succeeded. So not just, in this case, I'm using StreamReader to open the file and read the contents. So if the file is not there, or if the file is corrupt, then my StreamReader object would throw an exception, either a file not found or an I/O or I/O exception. And so in those cases, I'm testing, is the file actually there? Is the file corrupt? And then can I read the file? And then I'm going to look, can I find anything that is in that file that was not supposed to be there? So there's many different ways to write your Oracle, but the more checks you can have in your Oracle, the better. And then when you're in your Oracle, if there's a problem, I want to be able to throw those different exceptions. And in this case, I'm throwing the exception in order to preserve the stack. So when I throw that exception, my test code catches that exception and simply rethrows it. Then I have the stack, so it's much, much easier to see exactly what went wrong during the execution of my test. But again, one of the things I want to stress is to separate the Oracle from the test code. The Oracle should be a method, a separate method that your test calls. The next piece of advice is around logging and commenting. I have to be honest here. Up until about 2 years ago, my idea around logging and commenting was that nobody really wants to parse through miles and miles of log files, and hundreds of thousands of bytes of log files, especially if the test is passing. Since then, I have to say I have changed my tune dramatically, and I would say you probably need to log more information than you actually think you do. As a general rule of thumb, my colleague Alan Page once said that if you can't determine the cause of a failure from your log files, you're probably not logging enough information. And I do think he's absolutely true. I can't tell you how much time testers spend at Microsoft trying to debug test code. It's absolutely phenomenal how much time we spend debugging, and it's almost wasteful when you think about it. If we simply write a few more lines of code in our tests, then we can probably capture the right stuff to help us reduce our troubleshooting time when we have a test that's failing and blocked. One of my colleagues in our team, a developer, said that when he's thinking about test code, he's thinking about 50% of the test code should be logging steps. And interestingly enough, he was about right. The logging that we do is probably about 50% when any major execution step is either being logged as a test step or a comment, and I'll talk about those in a minute. There's also commenting. So this is in-code commenting that typically is not reported out to the log file or captured in a log file. But the importance of log file or commenting in your test code is that at some point in time we hand our test code off to somebody else. Somebody else is going to be looking at your test code, and nobody can read your mind. And sometimes, even if we go back to the test code that we wrote 3 months ago, we look at that code and we go, "Oh man, what was I trying to do here?" So if you write a comment in your code, if you just inject a comment to explain your train of thought at the time, it really helps others and even you jog your memory to understand what is going on. Also, sometimes we have to write something in our code that seems a little odd, and when somebody's looking at reading through your code, they'll come across a step in your code that just seems out of place or raises a question. Why are we doing this? Sometimes we have to put in a workaround because of a bug. And if that is something that you have to do, then you should explain that and, of course, link it back to the bug in your code, so or in your bug tracking database, so people know exactly why you're deviating from what may appear to be normal to them or looks a little bit out of place. So here, in this case, I've added logging. I've added my logging steps to my find replace text test. And one of the things that I've implemented in my testing framework that I use for my students is a test step. So the test step should correlate with the steps that are outlined in the summary for the test method. And then I also have a logger.comment method for additional information. So when I when I launch Notepad, then I know that I'm calling a method that will launch Notepad and return the process. And so if my process is null, that method is actually going to throw an exception. And then when I call my method for GUI helper get foreground window handle, if that handle is null or int pointer 0, then I'm going to throw an exception and my test is going to be blocked. So every time I make one of these calls, then I'm going to also validate those methods that I call validate and make sure that I'm getting back the thing that I need to get back. Even when I close the application, I'm making sure that that application closes normally, and if for some reason it doesn't close normally and I have to kill the process thread, then that will actually throw an exception as well. And you can and previously you saw that if there's a failure in my verify replace, I can't find the file or I don't have enough memory, then that'll throw an exception. And in any of those cases, until start to finish, as this test is executing, if I launch my Notepad, I get my process object, but then when I try to get my main window handle, I know that that's what I'm trying to do. At that point, I can see, yes, that's what I was trying to do. If the handle comes back as int pointer 0 or null, I'll capture that exception. All that information, I know exactly what point in my my test failed, and the exception will actually tell me exactly why it failed. And then finally, cleanup. A lot of times when we go through, in this case, we have an initialize process, we have a cleanup process. Those are the things to put the system in a state that prepares it for the automation test to run, and then finally cleans it up after that automated test is finished running. Then there are comments in the code itself. So typically in my wrapper methods, I'm not going to spend a lot of time logging comments. Now, I could, and in fact there are some wrapper methods that I may want to, as in the case of my Oracle method, I did have it logging things to my log file. But in some of my other helper methods, I'm not necessarily, and this is the method for the replace all text, I'm not going to have it logging stuff, but I do in fact want to put comments in there so when somebody looks later at this code, they can understand what the purpose of this method is supposed to do, the types of arguments it takes for the parameters, and then it literally steps through from a very high level. I don't need to put a comment in for each program statement, but it gives me an idea that in this case, click menu item is calling a method from my GUI helper library, and I'm simply instantiating the find replace dialog, and I get the replace dialog handle. So this helps long-term maintenance and helps us remember what's going on. Also, again, make sure that we follow coding guidelines. So for style cop, we have our summary at the top of the method and things like that. So here I just wanted to throw in an example of the log file output, and I injected an error by not finding my dialog window. But again, we should be able to capture the information. I can see exactly in which step my test case execution failed. Not the test failed. The test is actually blocked, but the execution of the test failed. And so what actually failed during the execution of the test that's causing my test to be blocked? And so I can see that in the fifth line, that I actually called my statement. I made the program call to replace all text in a file, but then I throw the exception, and that's why I see my text blocked message. And then below the text block message, I see that I got a null exception, and my dialog window was not found. So for some reason, now I can go right back, look at Notepad, try to open up the find replace dialog, and see why it was not found and why I'm not getting a pointer to that window a pointer or window handle to that window. The fourth thing that I'll talk about is some common pitfalls that I see in a lot of test code. One of the things that I see quite often in examples, and I know that they're just examples that we can see quite often in lectures and in test code, samples on the internet and things like that, is hard-coded variables. I think that there's a joke about, that logon of a web page is probably one of the most tested things in the entire world, because it seems that many examples of test automation seem to focus around automation. The problem is that they all seem to use Bob Smith as the username, and this is a password or something equally simple as the password. So it's amazing that one of the complaints about test automation is that it's too static. There's not enough variability. It doesn't give us, it just tests the same thing over and over and over again. Well, there's a reason why it does that, and that's because it's poorly designed to begin with, and we hard code test data, we hard code other things that should be variables in our tests. So in this particular case, I'm looking at the example that I'm using, and I see file open, and I see edit replace, and this is quite fine if this test is only to run on an English language version. But what about if we're going to test on German or Japanese or one of the BiDi languages like Hebrew and Arabic? Then of course this test would fail because they don't have a file open. Once it's translated. So hard coding variables is almost always a bad idea. The other thing is hard coding coordinates. So in this case, I can see in the edit click, they're actually looks like they're clicking coordinate values for where they assume that button is going to be, and set focus with the click method rather than setting focus with the window handle. And so what happens when the resolution changes, or what happens when you go to a different device? So these are things, when you write your automation, you have to assume that your automation is not going to be ran on the computer that you're writing that you're developing your automation on. The next thing is no exception handling. So when I look at this script, here, this is a great example of we're making assumptions that I try to open my dialog, I do file open, I expect that my file open dialog is going to be there, I try to get the handle of it, and then I click the button, I make a click to set focus to the file name text box. But what if that file name text box isn't there? So in this case, the test is just going to keep trying to chug through and trying to execute every step. And then what happens is you tend to get this cascading problem or cascading errors. And so we really, it just makes troubleshooting so much more problematic because nowhere in here are we actually catching any of the problems that might occur as this test goes on. Every time we have a state change in our program or in the thing that we're testing, anytime there's a state change or anytime that we're doing an action such as opening a file or closing a file and regardless of how we do that, we need to make sure that we understand, and this is what I meant by being a control freak, we need to understand the state of the machine or the various states of the machine and be able to prepare or be able to have our test code react to those different states and understand how we want to handle those things. And then finally, there was no oracle here, but then when I looked at this test again, and sometimes I see this in test code, even if there is an oracle, but I look at this and I wonder, is this really a test case or is this a macro? This looks surprisingly like many of the macros that we would write back in Windows 3.0 and 3.1 days, where Windows has a macro recorder, and it would simply record a set of steps that for something that you wanted to do, some program task that you wanted to do over and over and over again. You could record a macro, and it just executed those steps blindly. And that's the thing that popped into my mind when I was looking through this code is this really looks like a macro. It doesn't look like a test to me at all. The last thing I'll talk about is exploratory automation. This is starting to get a lot of attention. And one of the ways that there's just like exploratory testing, there's many different ways to think about it. When I think about exploratory automation, I'm thinking about variation in my test. How can I vary the data? How can I make my test more robust? And how can I get past some of the limitations of what we think today of our automation, and those being that my test is always doing the same thing over and over, and my test is not giving me new information every time it runs. And so every time it runs, I'm just testing Bob Smith with a login of this as a password. Why don't I have an account pool where every time I need to log in, I choose a different account and a different password, or I have an account pool in which one case I have to go through the account setup process all over. So there's different ways that we can introduce variation into our automated test, and that gives us a lot of and now every time our test is running, that test will then give us different information, but it's the same information, and I'll show you what I mean in a minute. One of the downsides to this is that managers don't like randomness in automation. So if you say that I'm using random strings or I'm using random numbers or something like that, managers don't like to hear that word randomness. They want their test automation to essentially give them the same level of confidence, and that's the purpose of automation, right? Is that you want your automation to give the team confidence that the changes between daily builds has not adversely affected or has not introduced new errors into the product. That's one of the biggest benefits that we see out of our automation today. So anyway, rather than call it random string generation or random walking for state traversals, I don't know, you have to call it something else, variation, equivalent variation. Choose something that makes that the managers don't quite grok, and everything will be fine. The biggest benefit for variation is, of course, you get greater test coverage, you get greater data coverage. So there's a lot, there's some good things. Additionally, by introducing variation, you could also find potential bugs that you didn't find with hard-coded data. Also, hard-coded data tends to be too generic. Again, one of the things that we see a lot is this Bob Smith example for login password. Well, in some cases, we tend to use in our automated tests, when we see hard-coded strings, it always tends to be ASCII characters, A through Z, uppercase or lowercase. Very seldom do we see a name with ideographic characters like Chinese ideographs, or with bidirectional characters of Hebrew, or a mix of various characters. And you know, this is the 21st century, so we have to be thinking Unicode. And we have to be able to, and if our products are not Unicode enabled, and they're not fully Unicode enabled, then we're not providing a full service to our customers around the world. One of the languages I like to test with is Hindi, because Hindi is a Unicode-only language. There is no ANSI equivalent encoding for Hindi. And so if I'm using Hindi characters in a stream of text and they become corrupted, then I know that whatever that the function that I'm testing is not 100% Unicode enabled. And someplace in the code they're trying to thunk back to ANSI. Of course, there's drawbacks to variation, especially with data, and that is unreliability. Sometimes we'll get false positives. Understanding your test data, understanding your state machines and the traversals between state machines is one way to solve that problem, but it really takes a lot of in-depth knowledge and a lot of expertise in those areas to solve that problem. And sometimes it's more work to implement variability into your test. So let's look at an example. In my one of the ways that I could introduce variability into our find replace test is, instead of hard coding Samuel Clemens as the find criteria, as the words to find in my text, what I'm going to do here is I'm going to read the text from the data repository. So I'm going to read the file in that I want to change, and I'm going to read all the words in that text document. And then I'm going to put those words into a list object that I later have to convert to an array. Now, in this case, I'm separating the words based on the space character. That could be a problem if it was using a language such as Japanese or Chinese. Then I'm not separating words per se. But in this case, I'm assuming that I'm just taking a regular document that's written in English. I'm going to separate on spaces, and every word is going to be put into an array, and I'm not going to have duplicates. And so then I'm randomly going to select one word out of that entire list of words that's contained in that document. And that word may be repeating. It may be only one instance. And so now, instead of having a static variable in my test code, now I have a method that's going to give me at least one word that's contained in the body of that text document that I'm using as my base. I can do the same now for my replace word. I can also create a method, but in this case I have to be a little bit more static than with my finding word method. And in that case I have to know what are the words that are contained in my base document, and then either have a list of words that are not in that document that I can randomly select from, or even more simply I can generate a random string and replace the word that I find, any word that my method gives me, and I can go to that document and then replace that with a random string. And so now when I go back to my test, I'm going to generate a seed value, so each test should have a unique seed. And one of the things that I didn't do here is I did not log the seed value, and that's a mistake. Anytime you're getting a random seed value, you should always log the seed value for that test. That way, you can, especially when you're introducing variation, you can always replicate the data. So either sometimes I'll log the data, but most importantly is remembering to log the seed value. With the seed value and you're using the same random generator, then you can absolutely 100% replicate the data. The other method, or the other change in my test code was to then call the methods, get find word method and then get replace word method, and these two methods simply replace the static variables that were in the original test code. And notice that now, even though I'm using a different find word, a word defined in my text, and I'm replacing it with a different word rather than, you know, finding Samuel Clemens and replacing it with Mark Twain, I'm now choosing different words every time my test case runs. But the oracle for this test case does not change. So the purpose of the test, to make sure that replace all works, has not changed. And even though I'm using different data every time the test executes, the purpose and the objective of the test remains the same. But now I'm getting a lot more data variation. Another thing I could do here is there's different ways to launch Notepad. I can launch it from the menu. I can launch it by calling the executable, so on and so forth. There's many ways to open the file. And so whether I navigate by key mnemonic or whether I open the file when Notepad launches. However, there's many different ways to achieve certain tasks within a test. So if I have different methods for achieving the same task that I want to achieve, opening up a file menu, things like that, then I can code those, and then I could even randomly select or randomly select one of those methods during program execution, and so I don't have to execute the same static set of steps each time if I didn't want to. So there's a lot of things we can do to improve our automation, and this is just a small sampling. This was just 5 ideas that I think that if we started to think about a little bit more and implement, it would really improve the design of our tests. And I think a lot of times one of the things that I see so often, especially in class, in my class and my students, is that I give them a task to achieve, and instead of really sitting down and thinking about the design and how I'm going to write this code, they just start writing code. And a lot of times, if you just step back and think about the organization, what methods or what steps are going to require more than 3 program statements, 3 to 5 program statements. That task should probably be a separate method. And if I'm doing it, maybe somebody else is doing it. So it should probably be in the framework, or the automation framework, or in a framework for that application. Organizing our test code using source control, using templates, helps improve maintainability. Really looking at the design, not producing this long script of program statements, but separating out multiple statements into different methods, really cleans up each test case. And now that you have these different wrapper methods to perform tasks, it really makes not just the test case read better, but it also makes writing tests a little bit more efficient, because now you're not having to write the same statements over and over and over again, multiple statements over and over, to achieve a specific task that's probably being done by different people, and probably even yourself in different tests. Logging and commenting, again, I've changed 180 degrees on this. I can't emphasize how important this is, because eventually somebody else is going to look at your code, or at some point you're going to go back and look at your code, and you're going to slam your head against the monitor and wonder in your brain, what were you trying to do? We have to get past the common mistakes. Hard-coded variables and magic numbers are certainly one of the biggest problems that I see so frequently in test code, and it really limits some of the ability and the robustness of a test. I also see that a lot of our tests are so U.S.-centric. Even tests that are written by non-Westerners tend to be very U.S.-centric, U.S. English-centric, and so we have to really understand and think about, things like language, things like even national conventions such as currency and number formatting and date formatting and time formatting. Those things are used, and if you're looking at a date format, or you're trying to get date for something, and you're assuming that the date is going to be in one format, but then it shows up in a completely different format because the test is being ran on a German language version, then that's a headache that you can easily prevent at the time when you design your test, rather than having to go back and fix your test code as soon as that test is executed on a non-English language version. And then finally, exploratory automation, using some variability, thinking about how are the things that, there's some tests like regression tests or unit tests. Those are perfectly fine to be static. But then there's other tests using static variables. But then there's other tests where I want to include a bit of variability. If I want my tests to be a little bit more robust, if I want them to provide different but similar information every time that test executes, I want to expand the test data that I'm using, or I want to traverse different states, program states, and achieve the program states through a different traversal, then I need to start thinking about exploratory automation. How can I enrich the value of my automation by doing this? Again, those are just 5 ideas. There's a lot more that we can go into, but that, of course, it would take more time, and we could probably go on forever of how to improve automation. But I want to thank you for your time, and I am ready for questions.
Okay, thank you very much for that presentation, BJ. We're now going to open the floor to your questions. I'll just open up my screen here first. So while you're typing your questions, let me bring your attention to our EuroSTAR webinar archive. Here you can get a recording, or you can view a recording of this webinar, as well as 90 other on-demand software testing webinars. You can also download the slides. And here's a look at upcoming webinars this month. We have a webinar with Rob Lambert entitled Moving to Weekly Releases, A Journey, and that's on the 25th at 2 p.m. And here's a look at some of the webinars we have next month. The first webinar is on the 8th with Jim Holmes, and it's entitled 4 Crucial Tips for Automating Your Web Tests. And our second webinar with Stuart Reed on the 22nd is Tester Motivation, the results of a 200 tester survey. So now we're just going to go through a few questions. We're gone way over time, so we're just going to get through a couple here. The first question I have for you, BJ, is can you define the advantage of having tests returned as blocked? If the test execution fails, does that not simply point to a test failure?
That's a great question. So, yeah, the value is that we want to differentiate between a test failure and a product failure. So when a test reports a fail, I'm assuming that there's a failure in the product code. I want to be able to say in my daily logging, in my daily reports, that I'm pretty sure when a test reports as failure that I have a high degree of confidence that my Oracle for that test ran correctly, and that there's a problem in the product that we either know about or is new, and that I have a high degree of confidence the product is failing. When the test is reporting blocked, that's something that if I own that test, I have to go look at that immediately, because it could either be reporting to a product, it could be either a product bug, something changed in the product that is causing a premature, or it's causing my test to abort, or that there's something wrong in my test code that I need to change, or maybe there's a product change that will cause a change in my test. So the blocks for me actually have a little bit higher priority because something went wrong out of the ordinary that I need to go investigate immediately.
The next question I have here is, how is the concept of equivalent variation different from parameterized testing, or are they the same thing?
Great question. It's the same thing. I think, well, parameterized. So I've given talks before around parameterized random data, where we're generating random data using specific parameters to constrain that data to make it look real. This equivalent variation is basically the same thing. My only thought there was, managers, anytime a tester starts talking about random, the hairs on the back of managers' necks starts to stand up and their eyes sort of glaze over. It's a word that most managers don't want to hear, and so we have to learn to call it something else.
Couldn't the logging be put inside the helper objects?
Could the logging be put inside? Oh, absolutely. You can log. When you're writing your wrapper method, you could put logging anywhere you want. And again, like I said, I've changed my tune 180 degrees on this. The more logging, the better.
Okay, we've gone way over time, so I'll just take one last question here, and it's quite a long question, so if you need me to repeat it, I will. The question here says, suppose you have a code base of 1,000 programming man-hours. If following all the guidances you suggest, how many test engineering hours would you estimate the test automation, how many test engineering hours would you estimate for test automating that code base? And if you use not all, but most important guides. Now, as I mentioned, it's quite a long question, so I will gladly repeat it for you.
Well, I'm not sure of how how those measures, the time it takes to write automation varies between individuals. So usually we count automation in lines of code and how much. But one of the things that I would say, and I think what the intent of the question is, maybe I'm misunderstanding it, is I have all this test code laying around, and I want to implement some of these changes. How long will it take me to do that? One of the things that I would say is don't work backwards. There may be some cases where if the tests are perfectly fine and they're running, don't fix it if it's not broke. So just let it, just let that sleeping dog lay. But if that test is broken, then maybe you should clean it up a little bit. But we should never work backwards. We should always work forwards. And so, I guess what I would recommend is don't worry about cleaning up existing code, but these are practices that might help you as you move forward to automate in your automation efforts. And then if something in your past sort of wakes up and is problematic, that's when you would go in and fix it. But I would not try to go in and just clean up hundreds of lines of code. I spent 3 months cleaning up one automation stack, and at the end of that period, not only did I lose more hair, but there were many days where I was going into the office and I simply wished that I had just completely rewritten the automation stack rather than trying to fix it.
Well, we're going to wrap it up there. Just want to say thank you to today's presenter, BJ Rollison, for the interesting webinar. Some great feedback there, seemed to be very enjoyable. And I'd like to thank all of the attendees for all your questions. The webinar is now over, so you can log out. Thank you, and goodbye.
Okay. Thank you very much.